find the derivative of the inverse tangent of x using implicit differentiation. The first step will be picking a variable. I'll use theta, because it's an angle, to be equal to the function we want to differentiate implicitly, which is inverse tangent of x. And, well, we don't know yet how to take the derivative of the inverse tangent of x, but we do know how to take the derivative of tangent of a function. So I will take the tangent on both sides here. This tells us that tangent theta is equal to x, because tangent of tangent inverse of x is just x. And now we are ready to take the derivative with respect to x on both sides. So we'll put down d dx and d dx. And on the left side, we know that the derivative of tangent of theta is going to give us secant squared theta. But we can't forget about the chain rule. We have to multiply by the derivative of the inside function. So the derivative of theta with respect to x is going to be the d theta dx that we're looking for. And this is equal to the derivative of x with respect to x, which is just 1. So now to isolate the d theta dx, I'm going to divide both sides by secant squared theta. So that tells us that the d theta dx equals 1 over secant squared theta, also known as cosine squared theta. Perhaps I will put down the squared in a different color so that we don't forget about it later. Now we know that theta is equal to the inverse tangent of x, and we know that tangent of theta equals x. So we can draw a right triangle. Here's our right angle, put angle theta right here. So if in a right triangle, tangent is opposite over adjacent. And we know that tangent of theta is x over 1. So opposite over adjacent is x over 1. And then if you use the Pythagorean theorem to find the hypotenuse, you will find out that it is the square root of x squared plus 1. Just the square root of the sum of the squares of the legs. And we need to find cosine of theta. In fact, we need to find cosine squared of theta, but let's find cosine first, and then we'll worry about squaring it. So we know that d theta dx is equal to cosine theta. Well, here's our angle theta. So cosine is adjacent over hypotenuse. But don't forget, we still have to square this. Now we have the square root in the denominator that will cancel out when we square it. So all we have left is 1 over x squared plus 1. And this is our derivative for inverse tangent of x.